Welcome back, my friends. Today we get to talk about success. Yes, one of my favorite topics, and I got Ed on camera with me today. We have 4 really great success stories with tooling, which is another one of my favorite topics. So Ed, we're gonna first start with deep hole drilling, aren't we?
Tony, we are. And Tony, thanks for having me. We are going to talk about deep hole drilling and the success that we've had with this drill. We run this on a large volume diesel engine block. What they did is they called us in. They were having trouble gaining tool life. They needed to drop their CPU and increase their tool life. We did all 3. So we brought this in, went up against the competition on the head deck bolt holes with the joint face. We gained from 90 parts that they were getting per drill, we upped them to 130 pieces.
Oh, wow.
130 blocks per drill. Everybody was happy across the board. It is now springboarded into 4 different applications on that same block line. That's how successful this drill has been. We brought in the 3 flute, added a flute to their process, increased their millimeters per rev, increased their cycle time. Engineers loved it. It's led to other successes.
That's amazing. Do I also see some areas for through coolant?
It is. This is a coolant through tool out of the spindle. We need high pressure coolant to run this, but most machines now that come out have the high pressure features.
Yeah, that's true. As a machinist, the first thing I would think about when I see a tool this long is how am I going to keep it stable when I'm going in there? How am I going to make sure that my hole is the correct size? How am I going to make sure that it doesn't break from any kind of out of balance, right?
There is a pilot drill that we pilot before this that acts as its bushing to go in and extend the tool life for the flute length that it needs all the way down.
Yeah, incredible success story. Yeah,
great question.
So yeah, being able to increase the tool life ultimately makes the company more money, and isn't that what it's all about?
That's what they like. Every time I walk in, we need CPU. We need to lower our CPU. That's where we step up and thrive.
And I thought it was all about your smile, but it is about the tools as well.
That helps too. That helps too.
All right, let's move on to the second success story, Ed. One of my favorite subjects is being able to take multiple operations and put it into one tool, and that's what you've done here, isn't it?
Bingo. That's exactly what we've done, Tony. What we've done, and customer comes in, I get excited to see their processes. I work with their engineering team. I'll say, where do you need to go? They said, we're doing this in 6 passes now, 6 different tools, 6 different operations. I bring it back to our engineering side. We work with them, we bring it down to 1 or 2, we drop them in. That's where that savings comes in from. They're happy, they've decreased their cycle time per tool, they've decreased their CPU, and most of the times their tool life has jumped up. That's where they drive their savings from. And you know, in this business, when you're running 1.5 million of these a year, they're looking for every second that they can pull out of cycle time. It's key to them. It's important to them. That's the MAPAL effect. That's what we bring to the table.
Ooh, the MAPAL effect. You know I like that, Ed. Something I bring up about this, and it might be a curiosity for someone watching out there right now, is if I've taken 6 operations and put it into one operation, am I taking 6 individual cycle times and then apply it into one tool so I still have the same cycle time, but I'm just having it in one tool? I know that answer is no. You've already said reduce cycle time, but that is a major difference in having it all in one spot, isn't it?
Correct, correct. And not only cycle time with the 6 tools, it's also machine magazine time to go through and work to take those, the time changing that's involved in the magazine is also critical now. Now you've only got 1 change in there going through instead of the 6 that you've had. You know, so that's a key to them.
Your buddy Jesse and I talked about that a little bit as well, because that's so important, whether it's limited holders that we have in our tool changer, or the fact that so many people are trying to get into automation now and run through the night to have all the tools prepped and ready to go and be able to run through the night. That's where tools like this come into play.
Bingo, you're spot on. That's where this comes in. That's where MAPAL thrives, is taking multiple operations, turning it into 1 or 2 tools, finishing a bore complete with it. That's where we're key. That's where we come in and we play a key role working with them. And that'll spring us to the next operation or the next part that comes in down the road. When they see another part coming in, they come to us and say, help us here on this. Can you help us again? That's where we really play a big part with them.
You know, I'm going to say it, you said it already. I think of butterfly effect, the MAPAL effect. I might use this one after every single tool we talk about. All right, Ed, what are we looking at with this one?
This is another Triton drill. So I had a customer, a large tier 2 customer up outside of Detroit, Michigan, that's producing ring gears. They run about 800,000 internal transmission ring gears, 4140 steel, I come in, I said, Tony, his name was Tony too, great guy, Tony. I said, Tony, where can we help you? He said, my drilling, I'm doing 16 holes on the part. He said, I'm drilling and chamfering. I said, can we bring in a tool? He said, absolutely. I said, what are you running now? He said, a 2-flute and I'm pecking. I said, why are you pecking? He goes, well, why wouldn't we? I said, Tony, can I bring in a tool? I worked with our colleagues here at MAPAL. We designed a tool. We saved them 139 seconds per part cycle time with the 3-flute Triton. We added extra flute in there, gave him more minutes in the cut, faster minutes in the cut. He thrived with it, loves it. He's still ordering 50 at a time today, plus regrinds. So that worked out very well for him.
The Triton tool seems to be an incredible opportunity for people to increase their cycle times, to have longer tool life. This is like the secret sauce of MAPAL as well. I really like that. But something I want to bring up is about that pecking. For the folks out there right now, when I was a machinist, I used to peck sometimes, and I used to have specific tools that could drive all the way through a tool. And I remember my tool life being a lot shorter when I was pecking, even though I thought it was a better way, even though I thought maybe I'm creating less smoke or fire that goes along with it as well. I got to peck in order to get through the part slowly. But with the right tool, you can dive right through, can't you?
The key, you are correct. The key to this tool is it's in and out of the hole so quick. That saves the cycle time, it saves the tool life. The customers love it because you just increased their cycle time at getting those parts off. And when you were producing 800,000 parts a year, that's critical to them. Every second counts, pulling it out, and that's what we did. And it was a cost saving, was a new customer, and he believed in us. He didn't believe when I ran the numbers for him originally. After we was done, he said, you were right, I was doubtful. We believed in you, and we got orders after that.
He is a believer in the MAPAL effect.
He's a believer in the MAPAL effect.
All right, my friend. On to the fourth one. This one looks kind of cool as well. What do we do here?
And this is one of my favorite tools. This is an Optimal Alu. And what we did, I'll let you hold the mic real quick.
Absolutely.
When we have parts like this where we have the lobes or the ears hanging out of parts, one of the biggest problems that the customers have is when they go in, they try to drill this. When they drill it, as that tool dulls, it puts pressure on that lobe. So on steering knuckles, especially steering knuckles, when they come in, I would get more customers say, we're moving in the fixtures. I said, we've got a solution for this. And they said, what is your solution? I said, we're going to bring in a 3-flute Optimal, and what we're going to do with this tool is we're going to helical ramp. And what that helical ramp does at 5 degrees or 7 degrees, when it goes down, it takes pressure off the part. When it breaks through, it cleans up the burr. There's no pressure there. They love that. The other feature that I added in with this is we made it PCD. This is diamond tip. So instead of getting their 3,000 holes with a solid carbide, we're now at 60,000 holes.
What?
We increased their tool life, decreased the CPU, and got them greater tool life. It was a win. They loved it. I don't know how many we've sold of these. I'd hate to count it up, but it's a lot. It is a lot of money savings for them, a lot of tools that we built for different customers. And it's springboards. Once I show customers what this tool has done at other plants that run similar, it's an eye catcher right off the bat. Bring them in, let's go. Stock standard, both carbide and PCD, they can have them tomorrow when they need them. So it's one of my favorite tools I've ran. We've had great successes with it. Once again, that's the MAPAL effect.
MAPAL effect. All right, I got 2 questions when it comes to this. Would you mind saying that number transition from before and after of how many holes?
Yeah, we were at 3,000 holes with a indexable carbide drill.
Right.
They took this. We're at 65,000 now.
That almost seems like made up numbers. It's so good.
Well, it's aluminum.
That's amazing. Still.
Yeah, it is.
From one to the other, regardless of material. Amazing.
Well, the other factor to this, the other driving force that the customer loved on this, they were at 32 cents a part when they tooled it up with Brand X, we'll call it Brand X. They were at 32 cents. By the time we retooled it, put the diamond tools on the part, they dropped it down to 9 cents.
Wow.
It was their lowest cost feet part that they had in the plant. They said, you guys have our lowest cost volume. And it was 400,000 knuckles a year that they were producing for this one particular car model. And it's led to many, many opportunities at this plant. It's really helped us.
So for all my engineers out there, do that math, leave it in the comments of how much money was saved based on the numbers that Ed just went through.
Bingo.
That's a big number. The second part of that question was, that was brilliant of you guys, because I imagine that shift in this knuckle, the shift in that part came from that first plunge, right? Trying to make that force instead of doing the interpolation to remove a piece of that material and hold it steady at that point.
Correct. You are right on the money. You have machined before.
Once or twice?
Once or twice. Yeah. The force that drill would go into, an indexable drill, when it would hit that part, and as it dulled, when the insert would get some wear on it, more force was created on the part, pushed it, then it would spring back when it would break through. With this Optimill, there was no spring back. They helical ramp down, boom. They clear out the holes, onto the finished ream, good to go. Done.
Incredible, Ed.
Yep.
This is the success that I like to hear. This is the MAPAL effect, much like a butterfly effect, but this is the MAPAL effect, and this is success. It's success that you can have as well. And much like the success on this table, you, my friend, have a successful interview also. So thank you so much for your time.
Thank you for your time.
Thank you all for watching. We appreciate your time as well. Manufacturing, we love spending time with you and educating you on some of the successes that are out there so that you can win within your factory as well. We appreciate you.